Hi, I'm Jeff Cogswell. Today at GoParallel, we're going to look at how to do some basic profiling in threading building blocks. Now, one thing to keep in mind when you're doing profiling of parallel applications, there's two ways you can profile. You can use what's called wall clock time, which basically means the actual amount of time that has passed from the moment the routine or set of routines starts to when everything finishes. The other way is to count CPU time. Now the problem with CPU time is if you've got multiple threads running, and let's say you've got, say, 10 threads running, and each one takes 3 seconds, and you measure CPU time, you're going to get the total time of all the threads combined, which is 30 seconds. Well, that's not really what you want typically when you're trying to measure how much your application sped up by adding parallelization to it. Instead, what you usually want is the actual amount of time passed from beginning to end, just the 3 seconds. In other words, you do want the wall clock time. So let's look at how to do that. Because threading building blocks works on both Windows and Linux and pretty much everywhere, I thought I would do this example on Linux. So let's start with a basic C++ file, and let's add some header files to it. I'll add my IOStream and the threading building blocks headers, and I'm also going to add a header so we can do some timing in it. And I'm going to add a couple using namespaces here. Now, to do the timing and threading building blocks, there's a handy template called tick count, and it includes a static function called now. So let's go ahead and do that. We're going to create an instance of a tick count, and we're going to call that tc1 equal tick underscore count colon now. We're going to call the now function of tick count and save its value back into our tc1 variable. And then we're going to go ahead and sleep for a bit. This particular sleep I'm using does microseconds, so we have to make sure we got plenty of zeros here. And then we'll call tick count again. And really that's all you do. And to find out how much time passed, you just subtract. When you subtract these two things, you get back an instance that has a seconds member. So we do tc2 minus tc1, and they overloaded the minus operator so that you can get back an object that'll have the seconds in it. We do that. And if I typed everything correctly, we can build this. And I didn't provide an output file name, so just a.out. And there we go. I had it sleep for 1.5 seconds, and it did exactly what it was told. I created an instance of tick count and did my sleeping, and then did another instance, and then I subtracted. And you can see it turned out just a little bit more than 1.5 seconds. Supposedly the usleep function is extremely accurate and will give you exactly what you want, but it took just a little bit more time to actually call into tick count and get the now, the value of now, and that's where the extra little bit of overhead is, but it's pretty close. And then we printed it out, and that's all it takes. It's pretty easy to do profiling like this in threading building blocks. Of course, for more advanced profiling, you'll want to use for example, the vTune product from Parallel Studio, but this works pretty well.